For this last problem, we're going to have an additional level of tasks to do because we're going to need to evaluate at the endpoint 0 and 1. So again, believe it or not, this actually has something to do with, this integral is related to the integral of a rational function. So we can use partial fraction decomposition on an integral like this. Okay, so let's get started. And the question is, how can we do that? Well, let's look at that integrand. So the integrand is 1 over 1 plus the cube root of x, right? So now, I think we can, this is much better, much better. So here's what I'm going to do. I'm going to let u equal that denominator, 1 plus the cube root of x. Now, the integral that I have is the integral of this dx. So I need to figure out what is dx, right? Does everybody see? So far, this is going to be 1 over u. And the question is dx, what is that going to be equal to? What does that translate into in terms of u and du? So I look at my equation here, which is telling me u is equal to 1 plus the cube root of x. Here's the trick. U minus 1 equals the cube root of x. So let's just solve for x. So x is equal to u minus 1 cubed. Did you see that? So what am I doing? Really, this is the same thing as x to the 1/3 power. So now if I have x to the 1/3 power is equal to u minus 1, then I can just take everything and send it to the power of 3. The 3 and the 1/3 cancel out, and I just have x equals u minus 1 quantity cubed. From here, I smile because it's really easy for me to say, therefore dx is equal to 3 u minus 1 squared du. Does that make sense? So up here, I'm going to have 3 u minus 1 squared du. So that right there, we can go ahead and write our entire u substitution. The integral of 1 over 1 plus the cube root of x dx is equal to the integral of 1 over u times 3 u minus 1 squared du, where u equals 1 plus the cube root of x, and dx is 3 u minus 1 squared du. Okay. So now I think we actually can simplify this right-hand side a little bit. So let's bring out the 3, or not simplify it, but we're just going to rewrite it. So we'll have u minus 1 quantity squared over u du. But now that I think about it, oh, I'm too close to the edge. Isn't that part of a song? Something like, I'm trying not to lose my head. Ha 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 ha. I don't know. I get confused with the songs. All right. So we're going to copy this, paste, okay, and this is equal to, and we want to say 3 times the integral u minus 1 quantity squared over u du. So I'm just rewriting what I had up top because I'm going to actually need to simplify this a little bit. Expand the numerator, so we'll have 3 times the integral of, expanding the numerator, we'll have 3 times the integral of u squared minus 2u plus 1. The denominator stays the same. Now I'm going to split it up, right? So split up this fraction. So I have u squared over u minus 2u over u plus 1 over u. Okay? Equals 3 integral of u minus 2 plus 1 over u du. I smile. Why do I smile? Because this is so easy. This is so easy. So I'm going to have u squared over 2 minus 2u plus the natural log of u plus a constant. Okay. Am I done? No. And the reason I'm not done is because, remember, this is a u substitution problem. My original integral is in terms of x. So I need to plug back that u is equal to 1 plus the cube root of x. So let's put here equals 3. 1 plus the cube root of x, quantity squared, over 2, minus 2 times 1 plus the cube root of x, plus the natural log of 1 plus the cube root of x, plus a constant. Okay. Am I done? Nope. The reason why is because we still have to deal with this, right? So I need to evaluate this at x equals 0 and x equals 1. So I found my antiderivative, but to finish off this problem, I need to evaluate it at x equals 0 and x equals 1. So this is a perfect time for cut and paste. Copy, paste. Okay. So because I'm evaluating it at the endpoints using the fundamental theorem of calculus, I actually don't need the plus c because it would just cancel out. So I'm going to evaluate this at x equals 0 and at x equals 1. And I'm going to get 3 times, now for x equals 1, let's zoom in here. So I'll have 1 plus, let's see here, so that'll be, I'm trying to have both of these in the window at the same time. So this is for x equals 1. 1 plus the cube root of 1 over 2. Okay, now that needs to be squared. Minus 2 times 1 plus the cube root of 1 plus the natural log of 1 plus the cube root of 1. Okay? And then that minus 3 times, we need to evaluate it at 0. 1 plus the cube root of 0 squared over 2 minus 2 times 1 plus the cube root of 0 plus the natural log of 1 plus cube root of 0. Okay. Now the cube root of 1 is just 1. So we'll just have 1 plus, so that'll be 2. 2 squared over 2. So that's 2 squared over 2 minus 2 times 2 plus the natural log of 2 minus 3 times, should just be 1 over 2 minus 2 times 1 plus the natural log of 1. What is the natural log of 1? It's equal to 0. So you can go ahead and we'll have 3. So that's 4 over 2, which will be 2, minus 4 plus natural log of 2 minus 3 times 1/2 minus 2. 2 minus 4 is going to be negative 2 plus natural log of 2 minus 3 over 2 and plus 6. And all this times 3. So we'll have minus 6 plus natural log of 8 minus 3/2 plus 6. The plus 6 and the minus 6 cancel out. And we'll have natural log of 8 minus 3/2. That's our final answer. How did I get that natural log of 8? What happened there? Was that magic? Was it voodoo? No, it was not. It was a property of logs. So looking at this, when I take this 3, so see I multiplied it by negative 2 to get negative 6. And now 3 times natural log of 2. So look at this. 3 times natural log of 2 is the same thing as the natural log of 2 cubed. Right, because at 3 I can put it on top. And that's how I got the natural log of 8. Because 2 cubed is 8.